Hi everybody, let's discuss some very important concept in computation, that is significant figures, decimal places and rounding off. So significant figures are an important topic in scientific computation in estimating quantities. To count significant figures in a number, we go left to right and find the first non-zero number. Then we count the remaining numbers including the first non-zero digit. For example, 1.23, in 1.23, the first non-zero digit is 1 and there are two more. So there are three significant figures in 1.23. Similarly, 1.0034 has 1 up front and has 4 more digits after that. So in total, there are 5 significant figures. In 0.0034, it has 2 significant figures starting from 3. Notice we ignore the leading zeros. So starting from 3 and ending at 4, we have 2 significant figures. Likewise, in 1.910, we begin at 1, which is the first digit, because that is the first non-zero digit as well, and we go all the way to the end. So overall there are 4 significant figures starting from 1 and ending at 0. For 7800 or 7800, which I haven't displayed on screen, I'll let you figure out on your own. You can pause the video if you want. But if you're following, I hope you agree that 7800 has 4 significant figures. So to repeat myself, from the first significant onwards, everything is counted. Leading 0, that is zeros before the first significant figure, are not counted. Now, decimal places is another very important concept. Decimal places are the number of digits after the decimal. So 1.91 has 2 decimal places because clearly there are only 2 digits after the decimal. 1091 has 0 decimal places because none of the digits comes after the decimal. 190 has also 0 decimal places because there's no digit outside after the decimal. And 10.91 has 2 decimal places because 9 and 1 are the only 2 digits that come after the decimal point. 1.910 has 3 decimal places, and I hope you can work out why. 010.91 has 2 decimal places because again there are only 2 digits after the decimal place. And now we come to another very important concept, that is rounding off the numbers. And this is important because sometimes we have to estimate quantities, and it is useful to round the numbers off because the numbers become smaller and are more convenient to discuss. For example, let's round off 2.4100 to 2 decimal places. This means keep no more than 2 digits after 2 decimal places. Sorry, keep no more than 2 decimal places. So no more than 2 digits after the decimal. So if we do that, 2.4100 becomes 2.41 because we keep ourselves to only 2 decimal places. Now how about 2.4150? Now you may guess that after rounding off it will become 2.41 because we are only keeping to 2 decimal places. But that's not the case. Instead, it becomes 2.42. But why not 2.41? And the reason is that because the digit after the second decimal place, which is 1, the digit after the second place, after the second decimal place, which is 1, is 5. So the digit at the third decimal place is 5. And as a result, according to the rules of rounding off, instead of getting 2.41, we got 2.42. 2. So I know that I haven't really told you the rules of rounding off, but I'm just building up to that. And in the next slide, we are going to discuss that. So let's practice some more. Round off 3.516 to do decimal places. So this becomes 3.52 because the third decimal place had a number over 4. So as a result, it becomes 3.52. So I've given you some hints about the rules of rounding off, but haven't detailed them yet. So here we go. So here's the rule. If you want to round off up to any decimal places, look at the digit right after it. So if the next digit is less than 5, leave the decimal place as is and drop the remaining digits. If instead the next digit is 5 or over, increment the digit at the desired decimal place and still drop the remaining digits. So if we round off 3.14159 to 3 decimal places, we get 3.142. Why? Because we go up to 3 decimal places to get 3.141, and see there's a 5 after 3.141. Hence we round the third decimal place up to 3.142. We drop the remaining digits. Similarly, if we round it off to 2 decimal places, we get 3.14. You can pause the video here and check it yourself, but I'll give you the reason. This is because at the third decimal place, we have a 1, which is not greater than or equal to 5. So we round down the second decimal place and get 3.14. Now, instead of rounding off to any decimal places, we can also round off to a given number of significant figures. So let's round off 3.14159 to one significant figure. To do that, we start counting the significant figures from the left. That is, we find the first non-zero digit. We find 3 is the first significant figure, and since we must round off to just one significant figure, we stop here and look at the next digit after it. The next digit is 1 because, as we see, we have 3.1. So the entire number is rounded down to just 3. Let's now round off the same number, but this time to 5 significant figures. Again, start counting the significant figures from the left. We find that 3.1415 has 5 significant figures. So we look at the next digit after 5 and find a 9 there. So the last significant figure, 5, gets rounded up to 6, and the overall result is 3.1416. So I suggest that you practice, take some self-help quiz. The link to this is in the description beneath the video. And with that, I'll just round up this video. Thank you for watching. I'll see you in the next one.